In 2026, SpaceX filed for permission to launch up to 1 million satellites, not for internet, not for navigation, for a data center, a computing facility the size of a small nation's power grid, assembled in orbit, 400 kilometers above the planet it serves. The filing dwarfs everything that came before it. SpaceX's own Starlink network, the largest constellation ever flown, is a fraction of that number. StarCloud, the most ambitious competitor, plans 88,000 satellites. SpaceX's proposal is more than 11 times larger. The company is not doing this alone. It is collaborating with Anthropic, one of the frontier AI labs, pairing the world's dominant launch provider directly with the intelligence that would run on the hardware. Launch, power, and compute. One supply chain, one company, no ground beneath it. And on June 12, 2026, SpaceX got the money to try. It began trading on the Nasdaq at $135 a share, a valuation just under $1.8 trillion, the largest initial public offering in history. The standard explanation is that this is a backup plan, a hedge against Earth's limits. The filing says otherwise. This is the primary strategy. The question is why a rocket company decided the future of computing cannot happen on Earth. The answer starts on the ground, in the places where data centers already exist. A modern AI data center is a factory that consumes three things in enormous quantities: land, water, and electricity. All three are becoming points of open public conflict. Communities fight new facilities over the water drawn for cooling. Utilities warn that AI demand is outpacing grid capacity. Land near fiber routes and power substations has become some of the most contested real estate in the industrial world. CNBC reported in 2026 that this pressure is not a temporary bottleneck. It is the long-term trajectory. The cost of building data centers on Earth is likely to rise for decades because the constraints are physical and political, not technical. There is no chip design that manufactures more rivers. Meanwhile, the opposite curve is bending down. Launch costs, the historic barrier to doing anything at scale in orbit, have been falling since SpaceX began landing and reusing boosters. The economic argument for orbital computing is not that space is cheap. Space is brutally expensive. The argument is that Earth is getting more expensive faster, and the two lines are heading toward a crossing point. That framing changes everything about how to read SpaceX's filing. This is not a moonshot bet on a breakthrough. It is a bet on two existing trends continuing: terrestrial costs rising, launch costs falling. No single invention required, just time. The companies that build AI models understand this arithmetic better than anyone because they are the ones paying utility bills that would embarrass a mid-sized city, which is why the most interesting name in the SpaceX filing is not SpaceX. The collaboration with Anthropic is the detail that separates this project from a decade of space industry vaporware. An orbital data center only makes sense if someone needs the compute badly enough to buy it before it exists. Frontier AI labs are the only customers on Earth with that profile. Their demand for processing power grows faster than any grid can accommodate, and their willingness to pay is effectively unbounded. Training runs are already measured in hundreds of millions of dollars. By pairing with Anthropic, SpaceX secured something no infrastructure project can survive without: a customer whose appetite justifies the scale. The scale is the point. 1 million satellites is not a data center in the conventional sense, a building with racks and cooling towers. It is a distributed machine. Thousands of nodes networked by laser links, orbiting in formation with computation flowing between them the way traffic flows across a terrestrial cloud. Starlink already proved SpaceX can manufacture, launch, and operate satellites in the thousands and network them in orbit. The data center filing extends that industrial capability by 2 orders of magnitude. The June 2026 IPO supplied the capital, pricing more than $555 million million shares at $135 each. The offering valued SpaceX just under $1.8 trillion, ahead of Tesla, ahead of Meta, inside the top 10 companies on Wall Street. The Washington Post noted the listing positioned Elon Musk to become the world's first trillionaire. Public investors just funded the attempt to move computing off the planet. What they bought is a claim on the one resource Earth cannot offer: power without a grid. The physics case for orbital compute comes down to a single orbital trick. One proposed design places the satellites in a sun-synchronous orbit, riding the planet's dawn-dusk line, the moving boundary between day and night. A satellite in that orbit almost never passes into Earth's shadow. Its solar panels face the sun nearly continuously. Every orbit, every day. No night, no clouds, no winter, no utility contract, no transmission lines, no community fighting the substation. On Earth, a data center's power is a negotiation with everyone around it. In that orbit, power is a property of physics. The sun delivers more energy in an hour than human civilization uses in a year. The constellation simply parks in the stream, but the same vacuum that delivers free sunlight takes away everything else. Researchers writing in The Conversation in 2026 catalogued the hurdles, and they are severe. There is no air in orbit, which means no convection. The heat that a terrestrial data center dumps into water, and airflow has nowhere to go except radiators, which must be large, heavy, and launched. Radiation degrades processors in ways ground-based chips never face. There is no maintenance. When a server fails in Virginia, a technician swaps it in minutes. When a server fails at 400 kilometers, it is dead hardware traveling at 27,000 kilometers per hour, and every dead satellite becomes a debris risk to the thousands of live ones around it. The engineering consensus is blunt. Reaching orbit is the solved problem. Surviving it, at data center scale, for years is not, which is exactly why the chip makers just entered the race. In March 2026, NVIDIA announced space-hardened computing platforms, including the Space One Vera Rubin module, processors engineered for the size, weight, power, and radiation constraints of orbit. The Rubin GPU aboard Space One delivers up to 25 times more AI compute than the H100, the chip that powered the first wave of the AI boom for space-based inference. Read that announcement as a market signal. NVIDIA does not build products for customers that do not exist. The company listed the firms already flying its accelerated computing platforms: Etherflux, Axiom Space, Kepler Communications, Planet Labs, Sophia Space, and StarCloud. 6 companies operating now, running NVIDIA Silicon in space missions. StarCloud's own plan calls for 88,000 satellites delivering on-orbit compute at scale, a constellation that would have sounded absurd 5 years ago and now ranks as the modest proposal in the field. Google is exploring clusters of its tensor processing units in orbit, extending its custom silicon strategy off-planet. Every major pattern from the terrestrial cloud wars, hyperscalers, custom chips, vertical integration, is reassembling itself above the atmosphere. The industry itself is not unanimous. Via Satellite reported in 2026 that even firms already flying hardware disagree on whether orbital data centers represent a genuine transformation or an expensive detour. In one executive's phrasing, the answer depends on who you ask and what problem you think space can solve. But the disagreement is about timing, not direction. No serious player is betting that AI compute demand shrinks, or that Earth's grid constraints ease. The race is on because the prize is not a product category, it is position. The Conversation, analyzing the IPO in 2026, captured what investors were actually buying: the potential for one company to become the railroad, electric utility, and cloud computing provider of the emerging space economy. That sentence deserves to be taken literally because no terrestrial company has ever held all three roles at once. The railroads of the 19th century controlled access, where commerce could physically go. The electric utilities of the 20th controlled power, what industry could run. The cloud providers of the 21st control compute, what intelligence can be built. Each of those positions alone produced some of the largest fortunes and fiercest regulatory battles in history. Standard Oil was broken up for less integration than this. SpaceX in orbit would hold all three simultaneously. It owns the launch capacity, the only road up. The dawn-dusk constellation would own the power, solar collection at a scale no grid rivals, and the data center itself would own the compute, with a frontier AI lab as anchor tenant. A competitor wanting to challenge any layer of that stack would need to buy rides on SpaceX rockets to do it. The $1.8 trillion valuation starts to look less like enthusiasm and more like arithmetic. Investors are not pricing a rocket company. They are pricing the possibility of a vertically integrated monopoly on the infrastructure of machine intelligence, one that happens to sit outside every border on Earth. That last detail is not a side effect. It is the part that matters most. Threshold AI publishes new documentaries every week on where this technology is actually heading. Subscribe so the next investigation reaches you. CTA. Every data center on Earth exists inside a jurisdiction. It sits on land, someone's owned, draws power, someone regulates, and operates under laws someone can enforce. When a government wants to inspect a facility in Virginia or Frankfurt, it sends people through a door. When it wants one shut down, it can cut the power. The entire architecture of technology regulation, antitrust, safety oversight, export controls rests on a single quiet assumption. The machines are on the ground and the ground belongs to someone. An orbital data center breaks that assumption. There is no door to walk through at 400 kilometers. There is no local utility to lean on because the power source is the sun. There is no national territory because orbit belongs to no nation. The 1967 Outer Space Treaty governs states, not server farms. And it was written 4 decades before anyone imagined a corporation flying 1 million machines. Now place AI inside that gap. The compute layer of machine intelligence, the physical substrate on which frontier models are trained and run, is the one point where societies can currently exert control. Chips can be embargoed, facilities can be inspected, power can be metered. Move that substrate off-planet into hardware owned by 1 or 2 companies, reachable only by rockets those same companies operate, and every one of those levers goes slack. The million satellite filing is real. The $1.8 trillion is raised. The space-hardened chips shipped in March 2026, and 6 companies are already flying them. The engineering problems, cooling, radiation, debris, are severe and they may delay the timeline by years. But the direction is set. The most consequential infrastructure of the century is beginning its move to the one place no civilization has ever governed. The civilization beneath it has not yet noticed what it is about to lose the ability to switch off. One company now controls the road to orbit, is building the power plant that waits there, and holds the filing for the largest machine ever proposed, while the institutions that would oversee it remain bound to the ground. The hardware will launch before the rules exist. That gap between what gets built and what can be governed is the story of the next decade. Threshold AI covers it every week. Subscribing is how the next episode finds you.